So this semester I worked with Mike Foster at the City of San Jose to assess the temperature and precipitation changes in San Jose between 1950 and 2050 using the CMIP5 model. And so because we were just looking at the City of San Jose, I only pulled latitude 37.33 and longitude negative 121.9. And I pulled variables maximum and minimum temperatures and precipitation rates. These were all monthly, pulled from the downscaled CMIP5 data, and that CMIP5 model is the Coupled Model Intercomparison Project Phase 5, and it's the same model used by the Intergovernmental Panel for Climate Change in all their climate change reports. And so getting back to the data, I pulled the 1 degree monthly general circulation model projections, and because this GCM does include multiple models with multiple ensemble members, I did pull all models with all of their ensemble members from all RCP scenarios, and those RCP scenarios are the representation concentration pathways, and they represent different CO2 emissions due to human activity. And throughout this presentation, the RCP 2.6 represents a decreasing in CO2 emissions due to human activity, and is represented in red, while our stable CO2 emissions are represented by RCP 4.5 and RCP 6.0, represented in blue and green respectively, while if we were to increase our CO2 emissions, it would be represented by RCP 8.5, which is represented in magenta throughout this presentation. So for the annual average maximum temperature, I created this graph for 1950 to 2050, and you can see that slight bias here due to the different numbers of ensemble members in those different models, giving a little bit different output between 1950 and 2000, but towards the end they kind of start to move back together, and RCP scenarios are represented very well in this graph. And you can obviously see in all scenarios there is a very strong upward trend between 1950 and 2050 for all RCP scenarios, with 8.5 being the strongest and 6.0 the weakest trend. And so to get a little bit clearer of an idea of this trend and how it is increasing, I did the decadal average of maximum temperature between 2000 and 2050, and you can see that they are all increasing very strong in that 8.5, and 2.6 is the strongest and weakest decadal average of maximum temperature. And to get an even clearer look at the maximum and minimum temperature trends, I took the 1950 to 2000 mean, and I subtracted it from the data points between 2000 and 2050 to get the temperature anomaly. So these are just the temperature differences from the 1950 to 2000 mean. And so as you can see, they all are positive temperature differences. So that clearly shows that the temperature will be increasing. And the only time it was decreasing was in these two instances in RCP 6.0 for the maximum temperature. So going on to minimum temperature, you aren't seeing that bias with the separation between the models here in the minimum temperatures, so that's good. And we are seeing a obvious increase in temperature for minimum temperature as well, and they are showing that 2.6 is the warmest, while 6.0 is the coldest in 2050, showing that maybe with the more CO2 emissions that minimum temperature could be colder than usual, but still warmer than 1950. And then moving on again to the decadal average of the minimum temperature, there still is that strong upward trend, with 4.5 as the warmest decadal average in 2050, while 6.0 is the coolest, but still again warmer than the decadal average in 2000. And then looking again at the minimum temperature anomalies, just like we did for the maximum temperature, they all are positive, and showing a except for the one instance in RCP 4.5, and on average they are showing about a 1 degree increase from that 1950 to 2000 mean, strongly showing that there will be a temperature increase in the future for that minimum temperature as well. Now moving on to precipitation, there is that bias again between the ensemble members for precipitation. However, there does not seem to be a very strong downward or upward trend. It seems to be very stable with the precipitation patterns for all RCP scenarios. And again, this shows in the decadal average, it's showing very kind of straight across, little variance between the decadal averages between 2000 and 2050. And then for the temperature anomalies, it shows a strong sporadic pattern between positive and negative from that 1950 to 2000 mean. So it shows that because it's so sporadic, there is no trend in precipitation patterns before 2050. So now my conclusions are that maximum and minimum temperatures will be increasing for all scenarios, with CO2 emission increasing, stabilization, or decreasing, as well as precipitation shows no change in those trends, but we could pull just the wet season and see if that has any trend and see if that's increasing or decreasing, but those have not been showed. And then for other future work, we could pull data through 2100 because that CMIP5 data does include all the way up through 2100, so we could see how the temperatures might change by 2100. Thank you for listening, and if you have any questions, you may contact me at kayla.novak@sjsu.edu.